Okay, team. So now we are going to go through our first lab. So this is the link to the ACE professional portal. I'll make sure to include it with the recordings. And if you navigate, navigate down, we are doing lab number 1. But before we go to it, there's an intro. I think the most important part of it is if you are doing these labs, you must have an SSH client and you must be able to do outbound SSH. So if your organization or your network does not allow outbound SSH connections, then you need to shift to your own connection or your own laptop for that matter. And obviously you need to have any recent browser would do the job. We prefer generally Chrome or Firefox. Okay, so now let's look at lab number 1. Again, I'll be walking you through the lab. We'll go through the lab guide and we will solve the lab together. So this lab is just meant to get us started with, make sure that we have access to the lab. So it's generally very simple. So let's just get started. So in this lab, we'll create 3 VPC and VNets, 1 in each cloud, Azure, AWS, and GCP. The purpose of creating these VPCs and VNets is to familiarize yourself with the user interface. Okay, so here we are going to leverage the VPC tracker. You can think about VPC tracker like a mini IPAM, whereby it before you go and create a new VPC, you want to check if you have used this address range anywhere across your multi-cloud environment. So what we're going to do is we want to create a VPC with a side range of 192.168.12, but we want to verify that this is not being used before we use the tool. So what I'm going to do, I already have access to my controller and Copilot. Again, if you already have access, then you should be able to follow along. Otherwise, you can just be with me while I go through the solutions. So there is on the controller, this is a tool that is available within the controller today. There is a VPC tracker. Obviously, I can also search here VPC tracker, and I can get to the same tool. And what I'm going to do is I want to check if the CIDR is used anywhere before I actually create a VPC with that CIDR. So what I've done is I've put the CIDR range. It says, hey, good news, it's not overlapping. The next step that the lab wants me to go to do is to create now the VPC with this CIDR range. So if I go now and get out of the VPC tracker and I go and create a VPC, I can click on add new. And what I generally recommend is for ease of troubleshooting is to follow exactly the guide. So we're gonna put this is actually a VNet that is going to be inside Azure. So I'm gonna put Azure. The account that we already onboarded in our lab is already there. The VNet name is going to be Azure US Central Spoke 1. And as you can tell from the name, the region is Central US. The CIDR range is 192.168.12. And it doesn't require anything on the unchecked. If you look at the screenshot, that's exactly what we've done. And if we are confident that everything's looking good, we can click on create. What this is actually doing is this is doing an API call into Azure to create a VNet in that particular region with that particular name. So the next step we're going to do after we create this is to go to the Azure portal and verify that this has actually been created. So let's just give it a minute. Let's go to the lab guide just to see what it wants us to do after this step. So we can go again to the VPC tracker to see that this new VNet now is already there. So if anybody tries again to do 192.168.12, it will say that this has already been used. Okay, next, as I mentioned, we want to verify from the Azure portal that this VNet actually exists. Let me just give it a minute. Okay, so the VNet has already been created. As you can see, this is the VNet. If you go back to VPC tracker, at first you might not find it. If I put 192.168.12, you can see it's not there. But what I can do is I can click on refresh. What this is doing, this refresh, is the controller is going back and APIing into the different cloud service providers that we have, and getting the information about the VPCs and VNets that have been created. Okay, so now you can see the 192.168.12. This is again in the central US. This is the new VNet, and now it's part of the VPC tracker. So if I were to go and put it again, it will not. It will mention that this address is in use. The next step is I can go to the Azure account, and I can go to the VNets. And one thing that's very important is you need to filter by your subscription. I am running on pod 147. So I will have to make sure that I am filtering on that specific account. And if I do, I can clearly see that the first VNet is the VNet that has been created. I can also zoom onto that VNet and look at things like the subnets. So you can see that not only we have created the VNet, we have created multiple public as well as private subnets, in addition to the gateway subnet. And you can see the route tables that are mapped to those subnets. So we basically create the VNet, we create the route tables, we create the subnets. All of that happens by just creating the VNet. Okay, so this was just part one, where we verified, where we use the VPC tracker to check if a range is being used in use. We figured out that it is not. Then we created a VNet, and then we went to the Azure portal to verify the VNet creation. Next, we're going to do the same for AWS, so it's going to be a bit quicker. I'm going to go again to create a VPC, and I'm adding the VPC. It is going to be in AWS, and this is the VPC name. The VPC region is US West 2, so I just need to get that right. Sorry, US West 2. The VPC CIDR is as follows, and everything else is unchecked. So let me just make sure I follow exactly. Everything else is unchecked, right? So it's AWS, US West 2, Spoke 1, the region is US West 2, and the CIDR range is 10.0.22. Once I'm confident that everything is good, I can click on the create button. And again, what's going to happen is the controller is doing an API call into AWS this time to create that VPC. And as you've seen in Azure, this will also create different route tables, different subnets. In AWS, there is the concept of the internet gateway that will also be attached to that VPC. All of this happens automatically for you. Okay, so now that the VPC has been created, which is the 10.0.22, you can even go back to the VPC tracker and you can click the refresh and give it a few seconds. Okay, so if you search now for the 10.0.22, this is the VPC we just created in AWS. And similarly for what we have done before, we want to verify from the AWS console. So I already have the access to the account. So if you go to the to the VPCs, my apologies, you will find we created it in, let me just verify, the region we created it in was US West 2. So what I should go here is to go to US West 2 and go to the VPCs. I will see this US West 2 spoke 1. What's nice is even if I go to the subnets, you can see how many subnets we have created. What we do in AWS is pair AZ, meaning there is 2A, US West 2 is the region, there is A, B, C, and D. For each of those, we create, for each of those availability zones, we create a public and a private subnets. So this is why you have 8 subnets, 1, 2, 3, 4, 5, 6, 7, 8 in total. Okay, not only we create the subnets, you will find that there are route tables that also have been created, each for the different subnets that are already created. All of this has been done by the controller. So we created the route tables. Even if you go to the route tables, you'll find all of these route tables. If you go to the internet gateways, you will find that there is this internet gateway that has been attached to the VPC. All of this has been created by the Aviatrix controller. Okay, so moving on, the last VPC we need to create is in GCP. So let's go back to the GCP VPC. Let's go to create a VPC. This time we are going to G-Cloud. We already have the account. The way the GCP differs is that the VPC could be a global VPC. Thus, the thing is, whenever you create a VPC, you do not actually create it within a region. A VPC in GCP can be a global construct. Whenever you create a subnet, this is where you can tie the subnet to a particular region. So if we create the VPC, now we can add in the new role to create the subnet. So let me just follow. So we can create the subnet. The subnet name is going to be GCP US West 2 spoke 1 The region is going to be US West 2. US West 2, right? Yeah. And the CIDR range is going to be 172.16.22.0. And I guess that's it. So now I can use the create button. For GCP, we will not be verifying from the console. We'll just use the VPC tracker to verify. So what we have shown in this lab is how you can use the VPC tracker as a mini IPAM, and how you can create VPCs and VNets in AWS, Azure, and GCP. Okay, now that the GCP VPC has been created, you can even go to the VPC tracker. If you try at first to check the CIDR range that we created, you will not find it. So what you could do is just to refresh. Again, what this is doing is it's calling for the CSPs in order to get the new VPC details. Okay, so if we search again again, this is 2 pages, so you can scroll to the second page. But if you search for easier for 172.16.22, so yeah, this is the GCP subnet. I always forget because basically GCP does not have the CIDR range. If you click on the view gcloud subnet, again, the VPC does not have a CIDR range. It's a global construct. It's the subnet within the VPC that is mapped to a region, and this is the one that has the CIDR range. This is the reason why you do not see the CIDR range next to the VPC, but you actually see it next to the subnet. Okay, so this concludes lab number 1. Now we will move back to our lectures.